Okay, kind of picked up where my tablet shut me off there. So negative 2/4 would reduce to negative 1/2. So now we're going to get x to the negative 1/2 power. So we can't have a negative exponent here, so let's just make it positive. So we're just going to write that as 1 over x to the positive 1/2 power there. Okay, on number 11, we got x to the 2/5. Now I believe our directions on this here were to write this in a radical form. So recall, if we want to write this in a radical form here, the denominator tells me what kind of radical or what to put in the index, and then the 2 here, the numerator, is just the exponent or the power on it. So this is just simply the 5th root of x squared there. Now number 12, we have to do 5x to the 1/2 power. Now notice that the 1/2 power only applies to the x right there. So the 1/2 power we should have memorized by now just means the square root. So this would be the square root of this x. However, it would not be the square root of that 5 because the 5 is not being raised to the 1/2 power. So this would just be 5 times the square root of x there. Okay, on number 13, now notice the contrast here between 12 and 13. In the case on number 13, the 5 and the x are being raised to the 1/2 power, so that means both of them would go under the square root symbol this time. So this would be equal to the square root of 5x. Now number 14, now this time we have a negative exponent. So before we write it in a radical, we want that exponent to be positive. So we should know to write this as a positive exponent, we would just do simply 1 over x to the 3/4. Now that it's positive, I can write this in a radical form. So this will be 1 over, and remember this is going to be the 4th root of x cubed. Now number 15, now we have a decimal, and on top of things the decimal is negative. So let's do this first. Let's make that positive. So that's going to be 1 over x to the 1.4. Now it's kind of difficult to write the 1.4 there in terms of a radical. So what we need to see we need to see 1.4 in terms of a fraction. And once this exponent is in the terms of a fraction, we can write it as a radical. Now 1.4, let's write that in terms of a fraction here. That would be 1 4/10. And 1 4/10 would reduce to 1 2/5. And 1 2/5 here, that would be 7/5. Okay, so now let's rewrite that now as 1 over x to the 7/5. Now we can put it in radical form. So this would be 1 over, this would be the 5th root of x to the 7th. Okay, on number 16, we just had to simplify this expression here. So with 216, the way we can simplify this is to take 216 and write it as some number to a power in order for this to cancel out when I raise a power to a power. So again, this is what my cheat sheet is really good to help me for here. I can look up and find that 216, I'm pretty sure here this can be written as 6 to the 3rd power. Let me check that real quick. I don't have a calculator right now, so, or a cheat sheet. So yes, that is 216. Alright, so I can write 6 to the 3rd power to the 2/3 power. And now those 3's will just cancel out for me. And so all I have left is 6 squared, and that's just 36. Okay, on number 17, we're not going to let this negative bother us here. We're Still going to write 8 with some exponent here. So negative 8 can be written as negative 2 to the third power. Now I'll write, that's my negative 8 or negative 2 to the third power raised to the 5/3 power. Now with a power to power, we can multiply, which means we can just cancel those out. So we get negative 2 to the 5th power, and so that would just be negative 32. Okay, on number 18, we got 125 to the negative 2/3 power. Now I don't like that negative there, so let's make it positive before we evaluate that. So let's do it as 1 over 125 to the positive 2/3. Now let's evaluate it since it's positive. So we'll do 1 over, now 125 can be written as 5 to the 3rd power. Now, so 3 to the 2/3 there, we're multiplying the exponents, so we can cancel those out. And we're just left with 5 squared in the denominator, so that's just 1 over 25. Okay, on number 19, we've got 243 to the negative 2/5 there. So I think 243 can be written as 3 to the 5th power. Now, let's make it positive first. Kind of got ahead of myself there a little bit. So now I can write that as to the positive 2/5 power. Now let's write 243 as 3 to the 5th power. Now my 5's will cancel out. So that's just really 1 over 3 squared, and 3 squared is 9. So it's just 1/9 there. Okay, number 20. Now we got 243 to the 0.2 power. Now we really can't, it's kind of hard to simplify that when we have 0.2. So what we want to do here instead is we want to write 0.2 as a fraction. Now 0.2 is 2/10, and 2/10 would reduce to 1/5. So I just have here 243 to the 1/5 power. Now we just wrote 243 in the last problem, I think. So that's 3 to the 5th. So now I can write this as 3 to the 5th to the 1/5. Now these will cancel here. So my answer there is just 3. Now number 21, we've got 81 to the negative 0.5 power. So again, let's change that into a fraction. So that would be negative 5/10, which is just negative 1/2. Okay, so we'll write this as 81 to the negative 1/2 power. Now we could have made that positive first. I just chose to go ahead and write it as a fraction first. Now let's make it positive. So we're going to write it as 1 over 81 to the 1/2 power. Now here's one. It probably doesn't benefit us to write this as like 3 to the 4th or 9 squared. I mean, we should kind of pick up by now that the 1/2 power just means square root. So that's just the square root of 81 there in the denominator, and the square root of 81 is 9. So that just leaves my answer as 1/9 there. Okay, on number 22, now we're kind of throwing in a variable with it. So we're going to write both of these individually here to the 4/3 power, and we're going to take 64, and we're going to write it with hopefully something that'll cancel. So I'm going to write 64 as 4 to the 3rd power there. So 4 to the 3rd to the 4/3, and then x to the 12th to the 4/3. And now by writing them separately there, I can cancel out a lot nicer. So these 3's will cancel. Now that leaves me with 4 to the 4th power, and for the 4th power is 256. And now here we can get 3 going into 12 4 times. So I'm left there with 4 times 4. Remember, we're multiplying with power to power. 4 times 4 would be 16. Okay, on 23, now let's take that negative 1.5 on this problem, and let's write that in terms of a fraction instead of a decimal. So negative 1.5 would be negative 1 and 5/10, which would reduce to negative 1 and 1/2. And we want that improper there, so that's going to be negative 3/2. Okay, now we're going to make it positive, so we're just going to put it to the denominator. So this would be 1 over 81 x to the 12th, and I'm going to make it positive 3/2 power. Now, let's get to the part where we can simplify it. So let's write them individually now to the 3/2 power. Now with 81, I can write that as 9 squared. And again, we'll write this sort of individually here or separately to the 3/2 power. Now, we can kind of go back canceling there. Alright, so those 2's will cancel. 9 to the 3rd power. Man, I really don't know what that is. So that would be 81 times 9, 729. Okay, and now here 2 goes into 12 6 times, and 6 times 3 is 18. So 1 over 729 to the 18th power. Okay, number 24. Okay, we're going to raise both of those to the 3/2 power. Now we're going to write 25 as 5 squared though. That way, when I do that power to that power and I multiply those powers to powers, those 2's are going to cancel out. So those 2's will cancel. That gives me 5 to the 3rd power, which is 125. And then here 2 can go into 6 3 times, and we'll say 3 times 3 there would be 9. Okay, on 25 we got 0.5, so we can do there. Let's just write 1/2 power for that instead. So I have 49 to the 1/2 power, and then x to the 8th to the 1/2 power. Now, you could take 49 right there and write it as 7 squared, but again, 1/2 power is one where I probably would kind of do that a little bit differently. 1/2 power just means square root. So that's just going to be 7. And now here we can say that 2 we go into 8 4 times, so we get 2x to the 4th power. Now number 26, now we got that 1.25 power. Now let's change 1.25 to a fraction so we can do this better here. So 1.25 would be 1 and 25 hundredths. And then 25 hundredths here is 1/4. And then 1 and 1/4 would be 5/4. So now let's raise them individually to the 5/4 power. Now I'm going to write 16 as 2 to the 4th. That way I get that simplifying by canceling there with those 4's. And now let's do x to the 8th to the 5/4 power. So here we go, those will cancel. And 2 to the 5th is 32. And here I can say that 4 goes into 8 2 times, and 2 times 5 is 10. So we get 32 x to the 10th. Okay, now we got 125x to the 6 to the 2/3. So we're going to raise both of them individually to the 2/3. And we're going to write 125 as 5 to the 3rd instead there. So we get 5 to the 3rd to the 2/3. And then separately here, x to the 6th to the 2/3 down. The 3's will just cancel out nicely there. And 5 squared is 25. And here, 3 goes into 6 2 times, and 2 times 2 is going to give me 4 right there. Okay, on number 28, and we're sort of doing the opposite of what we did earlier. So earlier we took something that was in a rational, or something with a rational exponent, and wrote it in a radical form. Now we're going to take something in a radical form and write it with a rational exponent. So let's remember here, in a square root, our understood index right there is 2, and then our understood exponent is 1 right there. So remember, we just take our exponent and put it over the index. Remember, the index goes into the denominator of the rational exponent. So the x to the 1/2 power there. Okay, 29 is pretty straightforward here. So we're just going to say x to, remember, say 3/4 power there. So that's just our rule there. How we basically, have that rational exponents and radicals are really the same thing. Now on number 30, we've got 6x all to the 4th power, and then we're taking the 5th root of that. So since all of this is being raised to the 4th power, and all of this is being taken the 5th root of, then that means all of 6x, in other words, the quantity 6x, would be raised to the 4/5 power. Now 31 is the same idea. Okay, so we've got all of this to the 4th power, and all of it is in the 5th root. So really 30 and 31 doesn't really make any difference. And what this shows us here is that exponents and radicals have the same rank when it comes to order of operations. It doesn't really matter if I would do a radical or exponent first. So this would just be the same thing here. All of 6x raised to the 4/5 power. Apparently there are two number 31s. Misnumbered it. Okay, now we're going to the equations. So these are radical equations. Remember our basic steps here. These you didn't have to check any extraneous solutions, so we're just going to isolate the radical, and then undo the radical, and then solve it. So we're isolate the radical, we're going to get rid of our 2 here, and so that's going to take that down to 4. Now we're going to undo our radical, so we're going to square both sides. Notice that 4 is positive, so I'm not going to have to worry about any extraneous solutions. So this is going to just give me 3x minus 2 equals 4 squared would be 16. Now we just have a really simple equation to solve here. It's not a quadratic or anything complicated. So we'll get 3x equals 18, and then 18 divided by 3 was give me 6. Okay, number 32. Now we have this 1/2 power. Now again, instead of this 1/2 power, what we can do to kind of make us a little bit more comfortable is let's just call that the square root. Now, let's isolate it first. So I would add 1 on both sides here. So we would get 4 times the square root of x plus 2 equals 12. And then we can get rid of our 4. And that's going to give us 3. Now we're going to square both sides to get rid of our radical there. So we'll just get x plus 2 equals 9. Subtract my 2, and that's going to be 7. Okay, now on number 33, we've got us a rational exponent here of the 3/4 power. So remember, that's just a radical. Okay, we're still going to undo it at some point. Now we have to rationalize first, so I'm going to add my 4 over first. Of course, that's going to give me 24. Okay, now we can get rid of our 3. That's going to be 8 there. Okay, so now what we want to do is we want to get rid of the 3/4 power. So to get rid of the 3/4 power, what we can do here is just raise it to the reciprocal power. So the reciprocal of 3/4 would be 4/3. Now, of course, if I do the left side to the 4/3 power, I have to do the right side by the 4/3 power there also. So now all this is going to undo itself and just leave me with x minus 2. Now on the right side we have to simplify 8 to the 4/3 power. So I'll go over here and think I could write 8 as 2 to the 3rd. So that would be 2 to the 3rd to the 4/3. Those 3's would cancel, and then 2 to the 4th would leave me with 16. Now I just add my 2 over there, and that's 18. Okay, number 34. Again here, let's isolate the radical. So remember, this raised with this rational exponent is a radical. So I'm going to get rid of that 2 first. That's going to give me 54 over there. Okay, now let's get rid of this 2. So that'll be 27. Now let's get rid of this 3/2 power. So the opposite of something to the 3/2 power would be to take it and raise it to the reciprocal power, which would be 2/3. So everything here is just going to cancel out and leave me with x plus 1. Now with 27 to the 2/3 here, I'm going to write 27 as 3 cubed. So I'm going to do 3 cubed to the 2/3 power. The 3's will just go away for me, and 3 squared would be 9. Now we just subtract the 1 over, and that's going to give me 8 there. Okay, number 35, and we have 2 radicals on this one. So I take a little bit different approach here. With 2 radicals, what we need to do is kind of separate those radicals so we have 1 on each side. So this other one's going to go over here, which makes it positive. And now this is actually pretty simple here, because we can just square both sides and that gets rid of both radicals. So that leaves me with 7x minus 6 equals 5x plus 2. Okay, just a little easy equation here to solve. I'm going to subtract 5x on both sides here. So I'll give me 2x. Okay, now I'm going to add 6 on both sides. Of course, that's just 8. So we get 2x is 8. So we get x to be 4 there. Okay, number 36. Now, there again, instead of that 1/2 power, what we'll do is just think of that as being the square root of x plus 2. Now, let's solve it here. I'm going to add 1 on both sides to isolate my radical. Okay, I'm going to get rid of my 4 there. So that's going to give me 3. And now we'll get rid of our radical. We'll just square both sides. And then subtract 2 on both sides. That's just going to be 7. Okay, on number 37. Now this is different. Haven't seen one like this. The radical's already isolated. But notice it's not a square root, it's a cube root. So instead of squaring both sides, we would cube both sides instead. So that cube will undo that cube root. So that's just 2x minus 4. And then 2 cubed is 8 there. So now let's just solve this. I'm going to add 4 on both sides. That'll give me 12. And then 12 divided by 2 is 6. Okay, on number 38. Now our directions change here. And it specifies that we have to check for extraneous solutions. So remember, in between step 1 and step 2, it's the isolation step and the undoing the radical step. We have to make sure that whatever our radical, our isolated radical is equal to, that it must be positive. Now, this one is already isolated here. So we're at the isolation step. We're done with the isolation step. So what we have to be sure of is that x minus 5 is a positive number. Now we're going to undo our radical. So we'll square both sides here. So that'll undo the radical. That'll just give me x plus 7. And now x minus 5, quantity squared, we're going to square double square there. So that'll be x squared minus 10x plus 25. Okay, so now we've got us a quadratic, which is probably going to give me 2 solutions, but I'm going to remember, I'm going to come back here, and remember that solution has to give me something there that cannot be negative when I plug it into x minus 5. Now, it's a factorable quadratic here because to factor it, we want to set it equal to 0. And you'll see when I subtract these over here that this will factor pretty good here. Now negative 10x minus x would be negative 11x. And then 25 minus 7 would be positive 18. And now factors of 18 that add to be 11 would be 9 and 2. So we get 2 solutions here. Alright, one is 9, and then the other is 2. Now recall, this x minus 5 must be positive. Or it cannot be negative. It can be 0, or it can be positive. Now let's take 9, and if we get 9 minus 5, well that's positive, so that's okay. However though, if we put in 2, 2 minus 5 would be negative 3. And the square root of some value here, no matter what it is, cannot be equal to negative 3. There's nothing I can take the square root of that would make that work. Therefore, that 2 solution is extraneous. Okay, number 39. This is kind of similar. It's got a little isolation step into it first. So we're going to take that 2 over, get rid of it, so that'll make that say x minus 2 on the right side. Now there's my isolation step. So this is the part where I'm going to have to come back and check to make sure that x minus 2 is not something that's negative. Now let's undo our radical here, so I'm going to square both sides. So we'll get 2x minus 4 equals x squared minus 4x plus 4 by square double square there. Now let's do quadratic here, so let's set it equal to 0. So hopefully we'll be able to solve it by factoring. So now we're going to get x squared, negative 4x minus 2x would be negative 6x, and then 4 and 4 gives me 8. Now factors of 8 that add to give me 6 would be 4 and 2. So it's going to be both negative, x minus 4 and x minus 2. So our solutions here are going to be positive 4 and positive 2. Now let's check our answers. 4 minus 2 is 2, so that's okay. It's nice and positive. Now 2 minus 2 is 0. Now it is okay for the square root of something to equal 0. So the 2 is also okay. So actually both of them checked out for us that time. Okay, the last one I think here. Number 40. Let's isolate first. So we're going to throw that 3 on the other side here. That would be 2x plus 3. Now, we're going to come back in just a minute and we're going to ensure that 2x plus 3 is going to be something that's not going to be negative when I get my solution. Now, let's undo the radical. So it's a square root, so we're just going to square it. So we get x plus 2 equals, now let's square double square here, 2x squared would be 4x squared. And then twice our product. Now our product is 6x, not 3x. So if this is 6x and I double that, then that would be 12x. And then 3 squared, of course, is just 9. Now, let's set it equal to 0. So I'm going to get rid of these two on this side. So we're going to get here 4x squared plus 11x plus 7. Okay, now this will factor. We'll have to use the Berry method because we do have a leading coefficient. So now we're not looking for factors of 7 that add to be 11. We're looking for factors of 28 that add to be 11, which would be 7 and 4. So we're going to have 4x and 7 and 4x and 4. Now remember, we're using the Berry method, so we're going to have to pay back a 4 here, which will come back out of that one. So now we'll get 4x plus 7, and then dividing that 4 out, we'll get x plus 1. So we'll get negative 7 fourths, and then negative 1. Now let's plug those back in and make sure that they're going to give me something that's positive here. So let's see, 2 times negative 7 fourths would be negative 14 fourths. It's kind of hard to plug in there. Let me write that out for you guys. So this would be 2 times negative 7 fourths plus 3. Now 2 times negative 7 fourths, we'll do a little bit of canceling there. We could say 2 would go into 4 2 times. So we have negative 7 halves plus 3. Now negative 7 halves here, 7 halves is a number, or negative 7 halves is bigger than or smaller than 3. Because if you thought about it in that terms of a decimal, negative 7 halves would be negative 3.5. So you have negative 3.5 plus 3 would be negative 0.5. So what happens here is my negative 7 fourths is extraneous. Now let's put in negative 1. 2 times negative 1 would be negative 2. And negative 2 plus 3 would be positive 1. So that one would be okay there. And I guess that was the last one.